All right, so hey guys, I'm Nathan Fuller. I'm the CEO and co-founder of Fuse Machines. And so today we've been hearing a lot about how manufacturing is becoming more accessible as well as easier to use, right? That's what everybody's talk today has been talking about. And so Fuse Machines noticed that a lot of the users who are doing this are either engineers, product designers, or makers. But when they look at what they want to do and how they want to make their designs that they have, they run into some shortcomings. So traditional 3D printing is really cool. It's really flexible. It's really easy to use. But if you look at the parts, a lot of them come out kind of rough. It's more of an approximation. And so the accuracies and the surface finishes just aren't there quite yet, specifically with the FDM 3D printing. So on the other hand, CNC machining is really capable. We're able to go in and machine things to incredibly precise finishes and accuracies. But running a CNC tool is its own career. There are professional CNC machinists, and the CNC machines often cost large sums of money. So Fuse Machines thought that maybe we could marry these two, and we created a technology that we call dual sculpting technology. So dual sculpting technology is the intelligent integration of additive and subtractive in one tool and one piece of software. So what that means is that at any time during the printing process, we're actually able to come back and machine away those inaccuracies. So all those little parts and areas that you don't want to print start to go away. And so our customers are really interested in the technology, but what they really want is a solution. So I want to introduce you guys to the Orsis, which you guys can see sitting right here. The Orsis is the world's first desktop dual sculpting manufacturing platform. This means you can get machine-grade results on your desktop with all the ease of use that you're used to getting out of a traditional 3D printer. So I have to admit, I told a bit of a white lie in the beginning of this presentation. This part wasn't machined by a CNC machine. This was actually machined on my desktop, on my Orsis. And so we're actually able to get these results that are really different than what people are used to getting on a 3D printer, and we're really excited about what that can mean. So what exactly is the Orsis? Well, it started off with a really world-class 3D printer. So we built this printer from the bed up, which means that we had to start rethinking everything. So we had a precision ground piece of aluminum, which is cast to prevent warping. We have 600 watts of heated bed power, as well as a build tack layer, which is basically a third-party surface that really makes printing way more reliable. And all this is in an effort to make failed 3D prints, because anyone who's 3D printed something has had them fail. That's just not what we want. We want to make that a thing of the past. So that's really what we've tried to do here. Now, all this combined with our all-metal hot end, we actually print in a full enclosure, just like Plastic Fab does. And what that does is it creates a microclimate, which allows the materials in it to not warp as much, not experience as much stress. And so we're able to print not just in the PLAs and the ABSs, but also in things like nylon, polycarbonate, which is the same stuff bulletproof glass is made out of, right? So we're really working on pushing the limits of what people think they can do with this technology. But it's not just a 3D printer. The Orsis also has a 150 watt CNC spindle in it. So we can machine wood, plastics, and my favorite, we can etch PCBs. So imagine you're making a project, you can actually design the circuit board as well as the 3D printed parts and make them all on one machine on your desk. But perhaps the true power of the Orsis is using this dual sculpting technology. So on the your left, we have a traditional 3D printed part, and the other side you have a part that's been dual sculpted. And so what this really means is that instead of parts that are a rough approximation, I can create incredibly precise parts. So this gearbox is tolerance to 5/1000ths of an inch. That means you can create the same tolerances you get out of a machine shop, but again, sitting on your desk. And so I guess what this means is enough talking. So I'm going to try to do a live demo. So anyone who's ever done a 3D printer before is going to know that this is not always the easiest. It's going to start going in a second, but it's quiet enough that we can keep talking.
It's moving.
Yeah, so just this is a video you guys can watch. So this part was printed earlier. This is one of the parts that you guys saw in the gearbox. So it's been printed, and now it's actually returning, and you can see it as it shapes away those layers, right? We're not getting parts anymore that are layers and these little imperfections. It's actually a machine quality part. So I would, I just want to let you guys know that if you guys are interested and want to learn more, we have a special page on our website, fusemachines.com/newtech. There's a special offer there for you guys to get involved. And so that's it. That's how loud it is. So it's nice and loud, quiet enough that you can run it in the office setting. And so the cool thing is that if you guys want to learn more, feel free to reach out to me. Hit the after party. Thank you guys so much. Feel free to sit around and watch it make a bunch of mess. So.
Questions? Right on time. Good job. We got 10 seconds left.